how we can use the Python functionalities in the Pandas series. And also you'll be able to plot any kind of chart, like the line chart, the bar chart, or a pie chart. You can apply the tail, and tail gives the bottom 5 values, right? And if you want your custom values, you can give here the number, whatever you want. Let's say if you want the 20 values from the last, you can just give 20 and you will get the last 20 values. It doesn't work when we have the index as the integer, but if you have a series with the index as the labels, as the strings, it will work. So because we have a series. Hello friends, welcome back to the day 24 of 100 days of hell with Python algo trading. I hope you liked the previous session in which we discussed Pandas theory and then we covered few basic functions and attributes of Pandas series. Today we'll continue with that and we will cover some very important and frequently used functions of series. We'll try to cover most of them, and then in the next session we will start with again another absolutely important topic, that is Pandas DataFrame, right? So if you just give me few of your minutes, then you will be able to understand that how we can use some mathematical functions in Pandas series, and again how we can use the Python functionalities in the Pandas series. And also you'll be able to plot any kind of chart, like the line chart, the bar chart, or a pie chart. So without a further ado, let's get started. As we have already understood the attributes of series, okay, let's start some important series methods and which you will be gonna use frequently. So first we have is the head and tail. So before that, let me just print the series here and let's check it whether it's series or not. Type, yeah, it's series. So we are good to go. Actually, the name is df and generally we keep the name df of data frame. But for now, just consider this as a series. And actually, a series is nothing but a slice of data frame. It can be a column or it can be a row. So just consider this as a series for now. And actually, it is a series. So let's apply head. So head simply means the upper part, right? So by default, it will print out the 5 values from the top. And similarly, you can apply the tail, and tail gives the bottom 5 values. Right? And if you want your custom values, you can give here the number, whatever you want. Let's say if you want the 20 values from the last, you can just give 20 and you will get the last 20 values. And you can even apply the same custom values on the head and you will get the 20 values from the head. Next method we have is the sample. And sample means, let's say we have 100 values and we want a sample. So when we apply this sample method, it will randomly select any row and it will print out. Right? But if you want a custom value, that also we can get. So let's say we have df and sample. So when we pass without any value, we'll get a single random value. And when you again try to print, you can see that we are getting always a different random value, right? But if you give here, let's say a value and 5, then you will get 5 different values, right? And what is the use of this sample? Let's say you have a large series and in that, the values are sorted. So in top, we have the smaller values and the last we have the larger values. So if you just print the head or tail, you will get a biased value, right? You will not get a clear idea. So when you want to have a bird's eye view of the data, what you can do, you can simply find a sample values. Let's say if the item in your series is like 1000, then you can get a sample of 100 values and you will get the idea that how the values are there, right? So means you will not get the biased value in sample. Right. So next we have is the value counts. The use of value count is it will print the number of times, the frequency of any value in the particular series. When we apply df.value count, it will give us this result. And we know that most of the prices are not repeating. Only this one is repeating 3 times. So that's why we are getting 3. Else all the values are only once. Right. So you can also sort this value as per your need. So by default, it's ascending false. So you will get the descending value, and if you make the ascending is true, then you will get the value in ascending order, right? Next we have is the sort values. So if I apply sort values, then what will happen? You know that in this data frame, we have 2 things. One is index and second is values. So if you apply sort values, then these values will be sorted. And if you apply the sort index function, then these values will be sorted. So let's try this. Sort values and you will see that all the values are sorted, and also you can make it ascending is equals to true, and you will get the values in ascending order, right? And when you make this ascending false, you will get the values in descending order, right? Similarly, you can apply this sort index. One more thing, that if you apply the in place here, in place means the changes or the modifications you make will be permanent, right? If I make it true, then what will happen? The values in the file, the data frame you have, will be changed permanently, right? So make sure when you're applying in place, you are damn sure, right? Because when you are working in production, there will be no chances of mistakes, right? So you should be aware of that. Next we have is the sort index, and which will sort the index values. So let's apply on this sort index, and you will see that the index has been sorted alphabetically, right? And if you make ascending false, then you will get the values in descending order. You can see that we have first the small letter D, then alphabetically all the Z to A. Okay, now we have few mathematical methods which you will be using very frequently. So let's understand them. Okay, now the first mathematical method is the count. So let's apply on our df. So df.count, and you will see that we have the value of 50, because previously we created this series with the head method and we gave the 50 custom value. That's why we are getting the 50 value. And again, we have one more attribute here which we have seen already. And let me show you the difference between size and count. So what I'll do, I'll just print both of these, print, and I'll print the size also. So we know that the size is the attribute and count is the method. We know that in a class we have attributes and methods, and here we have the series class, right? So when I hit shift enter, we get both the values as the 50. The main difference is that size will also include the NN values, the none values, but count will exclude those values. But as here we do not have any NN values, that's why we are getting the same value. So in order to understand that, what I will do, I will create a simple series, size and count, and let's understand the difference between size and the count. So let's quickly create a series. So let's say math series, okay? Math series equals to pd dot series, and here we'll provide a list. So let's say 1, 2, 3, and here we'll give a none value. So that is, let's say NaN, small nan, and 4 and 5, right? And when I print this math series, it throws an error, says nan is not defined. Why? Because if you remember in the first video, I have shown you that whenever you import the pandas, please try to also import the numpy with that. So why? Because none values are from the numpy. So we have to write np.nan, and then to make it work, we have to import the numpy. I guess I have already imported that previously somewhere. That's why it is working. So, but still, let's import it again, and I'll import it here on the top. That's the basic convention. Okay. Now, when I hit shift enter, we get the value here, right, with the nan value. And let's try to apply these functions on this. So what I'll do, I'll just copy and paste this math series here and here also. And I'll remove this, and let's paste this here. And you can see that in count we are getting the value of 5, but in size we are getting 6. Means the size always include the NN values and count exclude the NN values. So that's the basic difference, and you should be aware of that, right? Now let's move to the next method, which is sum. So as the name suggests, it will sum all the values. So let's take the first series, that is df, and when I apply sum method on this, so sum, and it will give us the sum of all the values, right? Similarly, we have product. So if I apply product, it will multiply all the values and we'll get a large value, that is 1.08 e to the power 45. Now we have some statistical methods, and if you don't know the meaning of these, do not worry. We will cover these methods in detail in our statistics part in future. But for now, just understand that how we can apply these methods. So df.mean, and it will give us the average of all the values, right? Similarly, median, will give the median value. Then we have the mode. Mode is the value which is frequently repeating. Then we have standard deviation, and you will get the standard deviation. And next we have is the variance. So these all methods are very, very important in algo trading. And for that purpose, we have to cover this separately. Okay. But for now, just understand and just remember that we have these methods in Pandas. Next, we have is the min and max. And the name signifies that you will get the max and min values of any series. So df min, and you will get the smallest value. And for the max, you will get the largest value, right? And the last mathematical method we have is the describe. So the describe will give you the overview of any data set. So first of all, so whenever you want to have an overview of the mathematical methods, you can just apply describe to your data set. So let's apply that describe, and it will give you the whole mathematical idea, like the count, mean, standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, and the max value, right? So this is really important, and you should be applying whenever you want to have an overview of the data. Now we have is the series indexing, and in that the first topic is the integer indexing. So let's print our Pandas series. So for integer indexing, we have to have a series with indexes as integer. So for that, what we will do, we'll go up, and I guess we have created I think this is the series we can use for the integer indexing. So I'll just go and paste it here, right? And let's make it as int series is equals to, right? So now when I print integer, we have a series with integer indexes, right? So here it's same. I'll create another cell here. Let's create this. And here, if you give the integer values, so let's say integer series, same like the previously we have done. So you will get the first value. If you give the negative one, you will get the error. Because when you have the index as the integer, the negative indexing doesn't work. But when you have the label indexes, it will work without any error. So here negative indexing cannot work. Why? Because at this place you have to use the ilog and log, which I'll show you later, right? So for now, you just have to use the 0, 1, 2, the simple indexing, right? Next we have is the negative indexing, and we have seen that it doesn't work when we have the index as the integer. But if you have a series with the index as the labels as the strings, it will work. So because we have a series df in which we have the indexes as the strings, and if you apply here the negative one, you will see that it is working fine, 1.95. But it's deprecated, so it's better you use the ilog and log, right? Okay, next we have is the slicing. So slicing is simple, which we have seen earlier also. So let's say we have this series integer indexing, and here you want to print all the values. You just have to put a single column and you'll get all the values. But if you just want the 1 and the second value, so for that you have to give 1 and 3, and in that you know that the 1 will be included and 3 will be excluded. So you will get only 1 and 2. But if you are using on the label index, then the last position will be included. Let me show you. Okay, so I'll print this, and again what I will do, I will print df also, and let's slice that. So let me print it here again so we can have a look at the series. So let's print from BitTorrent to Shiba Inu, right? So I'll write here BitTorrent to Shiba Inu. So what happens here, integer index, what happens? So when we mention this 0, 1, 2 means 0 to 2, it will exclude this and it will print only this starting two values, which happened here. But in label index, if you print from BitTorrent to Shiba Inu, it will include all the three values. And that is the main difference between the integer indexing and the label indexing. So when you hit Shift Enter, you will see that we have all the three values, right? From BitTorrent to Shiba Inu. But in integer, we just have the two values because it always excludes the last position. So that's the basic difference, and you should be knowing that, right? Similarly, we have the negative slicing, which works the same. Integer indexing, then you can do like -3 to -1, and you will get the values. Let's say we have this series with the label indexes, and if you want to use the fancy indexing here, what you can do, you can give the BitTorrent first, and second you can give Pepe. So just give a comma, and then you can give the bonk. All will get printed out here. It says undetermined string literal. Okay, you have to apply here, and now it's fine. It says key of type double not found and not a multi-index. Okay, you have to actually use a list here. So just give a list. Now you are good to go. So let's also see the fancy indexing with the integer indexes. So what I'll do, I'll just paste it here and hit shift enter, and here we can use the integer series. So, and you give the values like 0 and 2. So you will get the position of 0 and 2. Just practice the multiple choice questions. Those are really good questions, and also the task questions. We have researched a lot on those questions, and it will be really beneficial if you practice those. Now next we have is the editing series. So we can again use the indexing. So let's say we have this series, right? And if you want to edit any value, let's say if you want to edit the index position 2, so you can just write 2 and change the value, let's say from 102 to 122. And when you hit shift enter and again print the integer series, it will be changed. So next we have is the what if an index doesn't exist. So let's say by mistake what you did, let's print it. You know that we have the index from 0 to 3, and by mistake what you did, you went here and instead of 3 you put a 4 here, right? And when you hit shift enter, you will not get any error. So let's do that. So what happened here? Just pause the video, just think what happened here. And if you know the answer, please let me know in the comments, and let's see how many of you are really understanding the concepts. If I print the series again, and you will see that we have another value with the index 4 and the value which we have given. Next we have this slicing. Let's say you want to change multiple values. Let's say I want to change this 1 index and the index 4. So for that, what I can do, I can use the fancy slicing, right? So for fancy slicing, I'll give a list and give 1, 4, and the value also we have to give as a list. So a list, and in which I'll give value, let's say 1000 and 1222, right? And now when you check the integer series, you can see that the value has been changed. Similarly, the fancy indexing is, let's say we have this series. Now let's change some value in the labeled series. So in fancy indexing, what we can do, we can give a list of values. So let's say if I give first the BitTorrent, and second, let's say I give the Pepe. So value of Pepe also 0.000012. So I'll just make it 1 and 2, simple. And now when you again print the df, you will see that the value has been changed. You can see 1 and 2, right? So that's how you can use the fancy indexing. Next we have is the using index label. Actually, we have done this. For this also, you can apply any value here. Let's say to change the value of algorand with the label and change it to, let's say, 10001. And now when you check the value of algorand, so you will see that it has been changed. Okay, now we have series with Python functionalities. Here you will see that we can use almost all of the Python functions in Pandas series. So let's apply the length. So length and df, you will get the length. And similarly, if you apply on our custom series, that is integer series, you will get the length as, you have to apply the length. So when you apply the length, you will get the length as 5, right? Okay, now I got some questions that where to use the square bracket and where to use the parenthesis and where not to use anything. So let's say we have these things majorly, the parenthesis and the square bracket, and also let's say we have some functions like length, and inside that we will include the df, right? So let's say df dot count, right? And also we have like df dot size, and also we have somewhere like, and here we are including the df inside the length function. So what is the difference actually? Let me show you. So whenever you see this kind of bracket, this is known as the parenthesis. So you can think that this is a method, right? And when you see without anything, you can consider that as the attribute of any class. If you see like this, then it might be an index for series or a data frame. You can write like series or data frame indexing, simple, right? And if you see like this, that data frame or any variable of pandas or Python is inside the any other function, then that is the simple core function, right? So basically in Python you will see only these four types, right? One with the bracket or the parenthesis, and one without anything, and one inside the square bracket where the value itself will be inside any another function. So we have seen that in a class we have two things. One is attributes and another is method. And so here you can see that this method is from the series class, right? Also this attribute is from the series class, and this is simple indexing, and this is a normal function, right? So that's the basic difference which I have discussed earlier also, and now also I'm discussing this, right? So you should be aware of that. It's very basic. Next function we have is the type. So you can check type of any Python variable. So let's say check the type of df, it's series. Let's check the type of ent, it's also a series, right? Okay, next we have is the membership operator. So we have seen previously. So what we can do here, let's first print the df and let's try to search Flocky here. So what we'll do, we'll just write Flocky in df. So when you hit shift enter, it says true. That means it is searching only in the index, right? But if you want to search something in the values and index, you know, right? Let me show you. This is the index and this is the value. But if you want to search in the values, and it will be applied in the values, and now it will show as the false. Let me remove this. It will show the false because it doesn't exist there. So in values, what exists? We know that 1.0 exists there, and when you hit shift enter, we get a true value, right? Next we have is the looping. So looping, what we can do, we can just write for I in df and just print I, and when you hit shift enter, you will get all the values. So make sure you know the difference. That so in membership by default it applies on the index, but in loops by default you will get the values. So if you want to apply on the index, you just simply write index and you will get the index value, right? And we know that we can apply any kind of function here in the for, and you can use it as per your requirement. And now I think you are able to understand that why we gave so much emphasis on the basics, the fundamentals, because the devil is in the details, right? And also you can apply any kind of arithmetic operator on the, so let's say you have this series df, and what you did, you just did df plus, let's say 100, and this is the best example of broadcasting. Means you are applying a scalar here and it will be applied to all the values of the series, right? Similarly, you can also apply the negative, let's say df minus 100, and all the values will be a negative with the 100. Similarly, we have the relational operator. So let's say we have this series. Let's say I apply df greater than 0.1, and when I shift enter, you will get the Boolean values. So if you want to get value, what you will do, you will use this as a mask and df, and you will get all the values which are greater than 0.1, and you will see all those with the examples and in a while. Okay, now let's check few examples of the Boolean indexing, and let's see how we can apply them in the real life. So here we have a question that find values which are greater than 0.1 but less than 0.4. For that, what we'll do, first we'll print out the data frame and we'll apply the condition, that is greater than 0.1 but less than 0.4. So we have to give the and df less than 0.4, right? And then hit just shift enter and you will get an error, right? So in order to avoid the error, what you can do, you can close these in the brackets like this, and Now hit enter, and you will see that we get all the values as the Boolean, false and true. And now in order to get the real values, you just have to make these as a mask, pass the df, and you will see that you have all the values which are greater than 0.1 and less than 0.4. And here you can apply as many as conditions you want. And that's how you can use this in your algo trading. Again, we have a question that says find number of values which is exactly equals to 1. So for that, we need to write df is equal to 1. And when you hit shift enter, and you will see that all the values are false except the one value. So let's check df. We have few more values, that is BitTorrent, DAI, Athena, USD, and Starknet. So now you can observe that how powerful this is and what you can achieve with this, right? Now we have some interesting part, and for which you are waiting from a long time. I know that. So let's see how easy it is to plot any chart in the Pandas series. So first what we will do, we'll just print the df, and then you just have to write a simple method that is plot, and just need to hit shift enter, and that's it. You will see that you have a plot. But now it's not looking that good because we have only few values, right? These ones. So for that, what you will do, you will just go back and again initiate the data frame. And now when you come back and plot the value, and now when you shift enter, actually I generally face this issue in Visual Studio Code. I don't know why. And for that, I need to restart my kernel. So let's restart again. So now when I hit shift enter, it will throw an error because again we have to import the data frame. So we'll just go back quickly, see where we imported the file. Okay, here we first importing from the CoinGecko with the API, and now we will export to CSV, and now import to CSV, and I guess now we will be having that. So plot, now we can plot that. So when we plot, because it is plotting the whole data frame, but as we are learning here the series only, so first what we will do, we'll convert the data frame to a series. And I think it will also good for you that you will also learn how to convert a data frame to a series, right? So what I'll do, I'll first print the data frame, and you can see that we have so many columns and the rows, right? 100 rows and 26 columns. So I just need the name as we had previously. So I'll write here the name and right the current price. And when you hit shift enter, you will see that we have only 2 columns, right? And one is with the index. But still we know that this is a data frame. Let's check the type of this, and you will see that this is a data frame. But what we want a series. So for that, what we will do, we'll create a new data frame. Now df dot set index as the name, right? And also in place is equals to true. And meanwhile, I'll just, now let's hit shift enter, and I'll just comment out these values. And now when we check the data frame, you see that we have the index as the labels. And again, when you check the type, it is still a data frame. So for that, we have seen that what we can do, we can simply squeeze it with the method and assign to a new data frame, right? So let's comment this also again. And now when you check the type of data frame, it is a series. So now we are good to go. So what I'll do here, I'll just print the data frame df, and when we plot this, you will see this beautiful plot. So here what is happening, only few values are very, very large, and because of that we are not getting a good plot. So what we can do, we can just sort that. So we know that by default it is descending. So what I'll do, I'll just print the below 50 values. I'll create a new data frame with that, right? And I'll just comment it out again. And now when I plot, you will see that we have issues. So what we can do, let's give it like explicitly. So now what we can do, we can sort this. So for that, what we will do, we'll write as df dot sort values, and ascending is equals to false. Okay, so let's check this, what we get. You can see that we have the values in descending order. What we can do, we can just get the tail 50 values, and we can create a new data frame. And I think now we can plot this and we should be getting a good. Actually, let's do this way. Okay, let's just take 20 values, okay, and plot them. And you can see that we have the line chart. And if you want, you can have a different kind of chart, like a pie chart or a bar chart. So for that, you just have to mention here kind equals to, and you will get a pie chart. And if you change it to, then you will get a bar chart. And you can see that we have a bar type and line chart. And this way you can create any kind of chart on any series. You just need to have a basic understanding and you are good to go, right? Okay, now in last we have some important series methods. So we have as type, between, clip, drop duplicates, is null, drop na, fill na, is in, apply and copy. So whenever I have a new data set, I always clean that first and I apply all these functions, all these methods. So let's say we have df here. If I apply as type here, okay, so here actually let's first check the type of this d type. So df dot d type, and you can see that this is a float 64, right? And if you check the size of this sys dot get size of, you will see that it is okay. For that you have to import the library, import sys, and you will see that this is 96, and I think it's very less, so it will not make much difference. So but still, let's check this. So I will just convert the data type of the data frame. So df dot as type, and let's say I will give d type equals to np dot int, and let's make it a new data frame here. Or let's just print this. It says np is not defined. We have to import the numpy also as np, and when you check, it is printed out and d type is integer 16, right? And if you check the size of this now, let's check it. So sys dot get size of, and you can print this also. Actually it's very small, so it will not make much difference, I think. And when you check this, okay, let's store this in something else. On the next line, what I will do here, I will just, let's make it dff, and now when you check the sys dot get size of the dff, it is 28. So you can see that it has reduced to almost 4 times of the original value. So now you imagine that you have a file of 10 GB, and if you want to reduce the memory footprint, you can use these kind of methods. If you know that we can store this value in some other data type and that can reduce your size, then you can definitely apply that method, right? Next important method we have is the between. So let's first print the series df, and here I'll apply between. I can give the value as 0.3 to 0.5, and when you hit shift enter, you get a Boolean result, and in which you will get only the values between 0.3 and 0.5. So sometimes it becomes so useful that those relational conditions, right? So you just have to use it as a mask df, and you will get only the values which are between the 0.3 and 0.5. Let me show you what you have to do. You have to first write df should be greater than 0.3, right? And df should be less than 0.5, and you have to close this in a bracket, not this whole in a bracket, and again this also in a bracket. Then you have to use it as a mask, and then you can print, right? So let's print both of these together and check whether we have the same value or not. So print, and let's print this also. So you can see that this between becomes so useful that you don't have to write the code with this, right? because these are some useful functions and it will really useful and handy. Okay, next we have is the clip method. So in clip method, what happens that if you give a range, so what will happen, all the values of the outside of that range will become same. Let me show you how. So let's first print the series here, and let's give a range like, and a range, let's say 0.6 to 0.7, or let's say 0.4 to 0.7. And when you hit shift enter, you can see that the value above 0.7 becomes all the same, and the value below 0.4 becomes all the same. All are clipped together. You can say that, right? So this is not that useful. You will be using more the between actually, but just still keep in your mind, it might be useful sometime. Next we have the drop duplicates, and it is one of the most important method. You will be using it a lot. Okay, let's say we store this in a new data frame, and let's say df, okay, 2 times. It's a new data frame, and when you print here df, you will get this, correct? So if you apply drop duplicates here, when you hit shift enter, you will see that all the duplicates has been dropped. So it becomes really useful a lot of times, but the issue here is that you will lose your data sometimes. You just don't want to remove the data, but you want to replace the duplicates. We will see that how you can do that, right? Next we have is null. Apply that on this data frame, df dot is null, and when you hit shift enter, all value are false because there is no null value. So if you want to test it, what we can do, we can, let's print the integer series here. Let's create a series quickly. So period series, and here we'll give an 1, 2, 3 np dot nan and 4 and 5, and now integer series, and if you apply is null here, it says true at this value because this is a null value, right? And if you want to check the exact value, you can use this also as a mask here, integer series, and you will get the third index as the null value. So this also you can use when you have a large data set and there might be so many values which are missing, and you can use this is null. So let's say you have multiple null values, so I'll make it also as null, nan, correct? And the last also I'll add another value as null, and now when you check, you will see that you have 3 values as null. So here how you can use it. Now when you simply apply is null, you will get a Boolean values. But if you want to check how many values are null, you can simply apply sum, and you know that the false are considered as 0 and the true values are considered as the 1. So it will just sum that there are 3 values which are null, and you will get a clear idea that how many values are null in your data set, right? Next we have is the drop na. So drop na is really beautiful function. So you know that there are 3 values which are null. So what you can do, you can simply apply integer series and drop an a and hit shift enter, and you will see that all the null values are removed and you will have a clean data set. Next is fill na. So what happens, sometime you just don't want to remove the rows, complete rows. Instead of dropping that, what you will do, let me again print this integer series and apply fill na, right? So what you will do, you will just fill with some string, let's say missing values, and when you hit shift enter, you will see that instead of nan, you are getting missing value. But sometimes you also don't want to fill with missing values, but a mean of that series or that data frame. So what you will do, you will just go here, and instead of missing values, you will apply function here, and that is integer series and mean, right? And you will see that you have filled the null values with the mean of that series, and that's also useful. So make sure you remember all these functions, all these methods here, right? Next we have is the isIn. So let's print the previous series, that is this one, and just apply isIn, and here you have to pass a list. So let's say we pass the prices, the 0.7, and let's take another price 0.11, and let's take another price 0.027. And when you hit shift enter, you will get a Boolean value, and in order to print that, you can use it as a mask, and you will get the two values. Maybe it was not correct, so you can remove this and you will get the two values, right? So with the help of isIn, you can pass a list of your desired value and you can get a Boolean value, right? Okay, now next we have the apply, and this is one of the most important function you will be using, and let's check it how you can use that. So in df, you can see that in the values we have all the float values, and let's say you want to round off these values. So just for the example, I'll show you that how you can use the apply method here. So df dot apply, and then you will use a lambda function here. So lambda x, and then you can round these values. So round, and here x, and let's say round it to up to two values, right? So now when you hit shift enter, you will see that all your values are rounded up to two values. And if you remove this two, then it will be by default rounded off to a single value, right? And it will become an integer instead of a float. Now the last method is copy, and copy is really useful because always you don't want to make any changes in your real data sets. So let me show you how. Let's say you have this data frame here, correct? And what you did, you just created a new data frame, let's say head, right? And with the name DFF, correct? So now in this DFF, you will be having only the top 5 values. So let's say if you change the value of flow, okay, flow here, you are changing the value in DFF, make sure, right? So let's say you make it as 100, right? So when you hit shift enter, and now when you check the value of DFF, you will see that flow is 100, Athena is the same and remaining the same. But here you made changes in DFF, but now when you go back and check in DF, you will see that the original value has also been changed, and this is not good. This is really not good. So when you want to make any changes, make sure you are using the copy method, because here it is not copying the value, but it is giving a view of the original Pandas series. So in order to avoid that mistake, what you can do, instead of just giving this, what you will do, you will create like df dot copy, right? And then you can create a new one. So let's say dfg, and now when you check dfg, you have this value, and you can make any changes. Let's say I'll make change to Athena, and I'll make it as 200, right? So let me add here. These are the code for the initial charts I have shown you. So if you want, you can use this. I'll keep it in here only, and I'll push to GitHub. So let's say now check the DFG, and the value is okay, Athena. And now when you check, you will see it's 200. But in the original data frame, when you check, it is still the same, right? So that's how you can avoid the mistake by using the copy function here. And that was it for this video. It was a very long video, but very useful, very critical. Make sure you learn all the concepts, and please solve all the MCQs and also the task. I was really tired in the last half an hour, but I thought let's make it. And sometime when we think we can achieve anything, so we just have to push our limits. We just have to push our boundaries, and that's it. So that is it for this video, and we'll see you in the next one. So until then, bye bye, take care, have a nice day.